regular hexagon, all the sides will be the same if it's regular, that's what it means. So all of these will be S, and the perimeter of this object is 50 centimeters, centimeters. So we can also, a perimeter, we can obviously go P is equal to S plus S 6 times, or we can write it as what? Yeah, so a perimeter would be 6S, and since perimeter is 50, we replace the P with 50, 6. Each side is equal to 50 divided by 6, you're right. So 50 divided by 6, 8.3. So on average, 8.3 repeated now. Okay, so some, yeah, a triangle is 180, right? There's 3 sides in a triangle. So 3 sides in a triangle, and if it equals 180. Okay.
There's 6 triangles in there's 3 in a trapezoid, and there's 6. Then there's 6.
You're probably right. We can probably put this into 6 triangles by 1, 2, 3. That would give us 1, 2, 3, 4. 4 triangles. Yeah. You could think of it like that. That's a great way to think of it. There's also a rule I can give you a quick hint on. For every side you add to a shape on a triangle, essentially. So every side you add to a triangle. So a 4-sided shape. Do you know how much that adds up to? 360, right? They're all right angles in here. So then once we get to a pentagon, which I had mistaken as a hexagon earlier, once we get to our pentagon, we add, what did we add in terms of our pattern here? How many degrees? Yeah, so we do the same pattern. We add 180, 540, and then if we add 180 to get up to here, we would get total degree being 720. 720 degrees is what all of these will add up to. We have 1, 2, 3, 4, 5, 6. Because they're 6 and they're all going to be even, we would divide this by 6, right? Alright, so every large S is 120 degrees. Good. So we got 120 degrees for all of our angles. We know that. We also know. So let's get a little information here. If this is 8.3, each of these sides, and each of those angles is 120. 120. Try not to get too clever. You get the idea, right? 120, 120, 120, 120. So we got quite a bit of information in here. Let's keep going. Okay, so what we've done is put some makeshift triangles on the outside. Essentially made this almost into a box, right? Square type or a rectangular type object. Okay, now we know straight lines. All right, a straight line is going to be how many degrees? That's right. So this straight line is going to be 180. So whatever is left over in there, we'll do it in blue. It's going to be 60 degrees. That's right. That's going to be 60 degrees. The hypotenuse of this is going to be 8.3. So already, according to our formulas, I got an angle and I have an hypotenuse. Can I solve for other sides of the triangles? Yeah, I can solve for other sides of this triangle here. Okay, is what we're going to need to do. We're going to need to do that. Well, actually, on the outside, we're finding the area of the shape. Another way we could go about this, what I was going to do, here's our goal, like I said, is I was going to find the areas of these triangles and the area of this entire square, and then subtract them. That's one option. Another option is to break this into a rectangular object here. Okay, so it's just 8.3 by, we have to find this distance, okay, and adding these two triangles to it. Both methods are going to work. It's just whichever one you essentially think of in the process, right? So let's go with what we had started with. We've added these sides to the outside, so we have 60 degrees. So let's find out what this is. We'll call this, the heights of the triangles we're going to call x, okay? And the widths of the triangles we're going to call our y's. And we'll put them in red. We'll call those our y's. So each of these is a y. We'll put a double stripe here, so we know those are our y's. And we'll put triple stripes for x, because I've already put one stripe for the hexagon side, right? So we don't want to technically mix those up. So we have those, and we know those are going to be similar objects. So let's go into it. What ratio do I want to use? If I have the hypotenuse, so remember these are our hypotenuse, this is what I'm talking about. We know what that distance is, it's 8.3. So we have a hypotenuse. Which side would you like to solve for? Okay, so the opposite of the 60 degrees, which is going to be which side? Well, if this is opposite, what letter is it? Y or X? X, that's good. Which of these ratios will we have to use? Okay, so let's see if we got this here. What would it be? Sine is equal to? And what is our opposite? Yep, that's right. X divided by 8.3 is our hypotenuse. Good. So we now have information to solve for our x. 8.3 times sine 60 is equal to our x. So 60 sine times 8.3, 7.18, 188. Okay. So those are the heights, okay, of both x's. So if one of those x's is 7.188, what's the total height of this box, or the width of this box we've made? Yeah, so let's call this, we're getting to lots of letters here, okay? Call it A. My A, we're going to do A times B to find out the total thing here. A is going to be 2x, 2 times x, right? We knew that x was that number, so 2 times 7.188, do you know what it is?
So 14.27.
Good, that's good enough. Centimeters, right? 37 centimeters. So the entire height of that, 14.37 centimeters. 14.37, is that what you said? Okay. Now, we got to find the other side of there. I'm going to use the exact same angle I have, even though I obviously know this is a right angle. Do you know what this one's going to be? Yeah, that's right. I want to, what other ratio could I use using this 60 degrees to solve for y? Tangent will give me opposite over adjacent. You're right, we do have the x, but I want to use the hypotenuse just because I had to round this number. So, yeah, let's use cosine 60. Okay, so read it to me. How would this go? Cos
60
good. Adjacent is our y. Great. There we go. 8.3 times cos 60. This is y. .15. I think we could say that, right? Is that what you got? Y equals 4.15. Now, here's a little tough part here. To find out, first of all, let's find out, we can find out, sorry, the areas of these triangles. All right, want to find out the areas of these triangles quickly? Do we have the information for it? What do we need? Okay. Yeah, that's right. Do we have the base and the heights of these triangles? We have the base. Use this triangle here. We have the base and the heights of these triangles. Let's spin it around a little, so it looks a little more like our triangles. What was the? Okay.
It was 7.188.
Great. So we got that information. This was our y and x, right? Yeah. Y and x. What's the area of a triangle? I'm going to call it AT.
Base times height divided by 2.
Great. Base times height by 2. Okay. So what are we going to get? I'll write it in here. You put it out. 4. You calculate for me.
29.83 divided by 2 is 14.91.
14.91. Probably round it to 15, but we'll be safe, right? You're not sure whether they want us to round or not. So the area of one of these triangles is 14.91. How many triangles do we have?
4.
4. So let's figure out what we got to subtract by, right? So what is the total subtraction area we're going to need? We're going to need 4 times the area of a triangle, right? To find out total area of triangles. So our area of a triangle was 14, so we do 4 times 14.91, right? So what's the total area of all those triangles?
59.64.
Okay. 59.64, is that what you said? Centimeters squared. That's important, right? So that's the total area of the triangles. Now, what should be the easy part? Area of this entire box. Okay?
4.5 plus 30.3.
Very good. That was the tricky part. You're right. We need to add, because of our y's being 4.15, are they? Or 5. To find out the actual width of this, we need to add both of those to 8.3, because that's only up to here. Good. So we get 8.3 plus 4.15, 16.6. So this is 16.6. So how do I find the area of that total shape?
16. Well, we got from the pictures.
Do we have it? I think we figured it out a while ago. Remember it all?
Well, it's
0.37, yeah. So let's go area of that total square down here in the end. Or, sorry, not square, but rectangle. Get this rectangle out. Okay, we had, what were the measurements? Do you remember?
14.37 and
16.6, right? It's right there on the calculator. Alright, so area of the square is what?
that's 16.6 times 14.37, 238.54.
Okay. 200.
38.54.
Is that it? Are we done?
We have to subtract the triangles.
To find what?
Find the total area of the hexagon.
Okay, so area of the hexagon is equal to area of square subtracted by total area of triangles. So I'm going to say 4 area of triangles. Okay, that's that number there. I'm just trying to use symbols that we've used throughout this. So the area of the hexagon is 238.54 centimeters squared. Subtract 59.64. So the answer is going to be area of a hexagon. 0.9 centimeters squared. Let's go on a limb. Let's say it is roughly 179 centimeters squared, the area of that hexagon. Okay? Does that make sense?